So let's talk about graphing this function now. 2x cubed minus 13x squared plus 24x minus 9 over 2x squared plus 7x minus 4. So what we're going to do first here is we're just going to go to our list. So here's the list. And the first thing it says, find y-intercept. So that's what we're going to do first. And that means my x is 0. So if I put in 0 for all of these x's here, you'll see that I'm going to get negative 9 over negative 4. And that's going to be for my y. That equals 9 over 4. Okay, moving, that's my first step. So my second step now, it says factor the numerator and the denominator. So that's what we're going to do now. So to factor the numerator, that's a cubic there. So that's a 2x cubed minus 13x squared plus 24x minus 9. So that means we're going to have to use the rational zeros theorem. So that means I'll take p, and my p is actually a factor of my 9 there, negative 9. So that's plus or minus 1, plus or minus 3, or plus or minus 9. And then for the other one, the 2 here, that's going to be my q, and that's going to be plus or minus 1, comma, plus or minus 2. So now we got to put all these together, talk about variations of p over q now. So plus or minus 1, plus or minus 3, plus or minus 9. So now think of it over the 2. So that's going to be plus or minus 1/2, plus or minus 3/2, or plus or minus 9/2. So now we have everything we need here to figure out which one works. And if I run through a lot of these, I'll notice that f of 3 equals 0. So now, once I find 1, I don't need the rational zeros theorem anymore, because that means I could use the factor x minus 3. Or I can just use the synthetic division and actually use the 3 and do synthetic division. So this is going to be a 2, negative 13, 24, and negative 9. And all I'm going to do here is do that synthetic division. Don't need that anymore now. So I draw my line, bring down my 2, that's 6, negative 7, negative 21, 3 times 3 is 9, 9 minus 9 is 0. So that gives us our 2x squared minus 7x minus or plus 3. That's what our new polynomial is. And we're getting closer to factoring now. So now I have this one, plus I have the 0, 3. So that means it's going to be an x minus 3 as a factor. And then I can break this down some more. I know this has to be a 2x, and this has to be an x. And now keep in mind that's a positive 3, so the signs have to be the same. And because the middle is negative, that means they're both going to be negative. And then I'm thinking of the number. So I just noticed if I put the 3 here and the 1 there, that's going to give me 6 plus 1 more is 7 because they're both negative. So that's the factoring of this. So I'm just going to write it up top here. So it's x minus 3 squared times 2x minus 1. And then on the bottom here, that's what we're going to do now. So get rid of all this stuff. Oops. Now that's going to be 2x and x. And that's going to be minus 1 plus 4. There we go. That's the factoring. Notice one thing here. Those cancel. So now that's still going to leave a hole there, but it's no longer going to be a vertical asymptote now because it canceled out. So that's going to equal now x minus 3 squared over x plus 4. And that's what we end up with now. Okay, so now we factored everything and we reduced everything here. So now let's take a look at the instructions for 2. Okay, we factored numerator, denominator. That's one we've done already. Okay, so it says find the numerator not common to the denominator. Determine where each factor of the numerator is 0. And find the x-intercept. So we got to find the x-intercept now. So check 3 x-intercepts. So the x-intercept is where my y equals 0. So that means where the top is 0, it will be equal to 0. So then I can see that my x equals 3, and that's the only one. That's what will make the top 0. So that gives me the ordered pair 3, 0. Okay, so now let's do step 4. Now step 4 says find the multiplicities of the x-intercept to determine the behavior of the graph of those points. I'm not going to worry about that one right now. So step 5 says factor. For the factors in the denominator, note the multiplicities of the 0 to determine the local behavior for those factors not common to the numerator. Find the vertical asymptotes. So 4 I'm not really going to worry about, but 5 is where I'm going to find my vertical asymptotes. And I only have one. If you look where the bottom is 0 at, that's going to be x equals negative 4. Oops. Because that's what's going to make it 0 on the bottom. So that's going to be my vertical asymptote. I should write that there. Okay, so now step 6. This one says, for the factors in the denominator common to factors in the numerator, find the removable discontinuities by setting those factors equal to 0 and then solve. Now the next one says compare degrees of the numerator and the denominator to determine the horizontal or slant asymptote. And we would say oblique asymptote for that slant one. And keep in mind we did 6 already because it asked us to come up with the removable discontinuities, and we did that already when we crossed out the 2x minus 1 there. Okay, so now number 7 says we are going to determine horizontal or oblique asymptotes. Now, notice the degree on the bottom is 1, the degree on the top is 2. So the degree on the top is bigger, so this tells me, and actually by 1 degree, so this tells me that it has an oblique asymptote. So I'm going to take the x plus 4 on the outside, and on the inside, I'm going to have to FOIL out that x minus 3, so that's going to be x squared minus 6x plus 9. So now with this one, we're going to try and do this long division. So what I got to multiply x by to get x squared? I would say x. So that's going to be x squared plus 4x. Now when I take that whole thing and subtract it, that's going to be negative 10x. And then I bring down the 9. So now, what do I got to multiply x by to make it negative 10x? So minus 10. So negative 10x minus 40. And then I take that and I subtract it. So that's going to be negative 31. Nope, hang on a minute. Because I'm doing minus and negative, so I'm really adding. So that's 49. So now, and also keep in mind the remainder doesn't matter here, just the qx. The qx is actually my oblique asymptote. So it's going to be y equals x minus 10. All right, now let's figure that one out now. Because because now we're going to have to graph it. All right. Let's graph the points first. So the first one is 0 and 9/4. So that's a little bigger than 2. Now remember, each notch here is 2 for me, so I just got to go a little above it. And then 3, 0, which is here. And then I think that's all. Now we do have a vertical asymptote at x equals -4. Now I'm down here, so I'm going to graph that one. And I have an oblique asymptote at y equals -10. So that line is going to be y equals x minus 10. And then what we're going to do now is we're going to graph this thing. We have enough information here. Okay, so first things first here. We can graph this one because this one makes sense. Cross here. But hang on a minute. Do I go through or do I bounce off? Notice the multiplicity of this number here, of this 0. It's 2 because the exponent is 2. So that means I actually have to bounce off of it. So if I want to draw this more accurately, it's going to bounce and go in that direction. So that's going to be the first piece. And then, now keep in mind here, I can either be over here or over here. And it's going to be one or the other. So what I'll do is I'll just pick a point. And I can pick -5. And if I pick -5 for x here, I don't put an equal sign there. That'll be a -8 on the top squared over -1. So that's going to actually be 64 negative. So what that tells me at 5, because remember that's 4 with the asymptotes at 5, which is here, that's going to be -54. So that's going to be down here. Now a lot of times when people graph these, they actually don't put the other pieces in. But it's essential that we do here. And you should label these points here. Like for instance, that point is 3, 0. And this point here is going to be 0, 9/4. So there's our answers for this one. One thing. Now remember, before we canceled, notice this here, that I did have a hole at 1/2. And if you think of it there, that's going to be right around here somewhere. And I'm going to have a hole there. So I'm going to create a hole. Now recall, it's going to be around 1/2. So there it is. And I'll have to put that in there too. If I have any holes, I got to make sure I add them. And then make a label for them. I'm trying to draw a nice little line to it. Yep, there it is. And I can draw a label for it. And I would say that it's going to be 1/2, comma, 25/18. Okay, so there it is. Now that's all the information I need for this rational function.